And as I mentioned previously, the domain controllers, you have these this hierarchical structure that starts with the forest, and then within the forest you have your trees, and then each tree can have domains, and then domains have leaf objects within those domains, which we talked about, for example, computers, printers, and users, and so forth. So smaller organizations most likely focus on OUs and their child objects. In other words, there'll be a single domain, and then they'll use OUs to organize everything within that domain. Whereas a larger organization might require an Active Directory structure composed of several domains, multiple trees, or even a few forests. The first domain controller creates more than just a new domain. It also creates the new tree and the root of the new forest. It may eventually become necessary to add domains to the tree, creating new trees and forests and add sites to the AD structure. And again, a lot of this you may have already planned ahead of time. So Active Directory does replication. Replication is the process of maintaining a consistent database of information when the database is distributed among several locations or many locations with Active Directory. There's intra-site replication, which is replication done between domain controllers in the same site. So intra-site is when we have replication happening within a same site. And then you have inter-site replication, which occurs between two or more sites. And then you have multi-master replication, which is used by AD for replacing AD objects. And how does it know what site? You actually have to configure that. So when you install a domain controller, you have to configure the name or the site that it's in, and Active Directory will begin to make this sort of physical map of where all these different servers are actually located. And you can even indicate exactly what kind of connection they have between one another. So it can understand the best path for the replication between these different servers. So you might have site A, site B, site C, site D, and so forth. And you can actually tell Active Directory how the different sites are linked to one another and what those links look like. And it will use that information to build that schema for replication. Knowledge consistency checker runs on all the domain controllers to determine the replication topology. So that's basically what figures out what that topology for replication is going to look like, that map that I was just talking about. And it defines the domain controller path that AD changes flow through and ensures that there's no more than 3 hops between any 2 domain controllers. So it wants to make sure that any 2 domain controllers can always get to each other without any more than 3 hops through these different sites. So a directory partition, each section of an Active Directory database, there are 5 directory partition types in an Active Directory database. There's the domain directory partition, which has all of the objects in a domain, including users, groups, computers, OUs, and so forth and so on. Then you have the schema directory, which contains the information needed to define AD objects and object attributes, so that schema that I talked about in the previous slide deck. The global catalog, which holds the global catalog, which is a partial replica of all the objects in the forest. We'll talk about why that's important here in just a few minutes. And the application directory partition, which is used by applications and services to hold information that benefits them. And the configuration partition, which holds configuration information that can affect the entire forest. So there are these things called operation master roles. So several operations in a forest require having a single domain controller called the operations master with sole responsibility of some function. So there are some things that you can't distribute, basically, right? So it's a distributed database, but there are certain things in Active Directory that you have to have one person in charge. So this is the thing: is Active Directory is not a pure distributed database, because there are certain things in Active Directory that are central. In the old version of Active Directory, going back before Windows 2000, you had basically what was called a primary domain controller that was the central authority, and then all of the other domain controllers were subordinate to that central authority. In the new version of Active Directory, after 2003 and forward, it was a multi-master. So in other words, it's a truly distributed system. But there are certain things that there's problems with being fully distributed. Having a distributed database has there's some risks there. For example, DNS has, any of the problems that we talk about in DNS is inherent because of its distributed nature. So to mitigate those risks and those issues, certain portions of Active Directory are still a centrally managed function, and you have what's called an operations master, which is responsible for that function. So there are 5 roles. There are 5 things that have to be centrally managed in a Active Directory domain. Those are the schema master, the infrastructure master, the domain naming master, the RID master, and the PDC emulator master. So starting from the top, the schema is, we talked about what the schema is. Well, the master of what the schema looks like for Active Directory, in other words, what that definition is for what all these different schema classes, or what object you can define and what attributes are about those objects you can use, that all has to be managed by the schema master. If there are any changes to that schema, it must be replicated from the schema master. The schema master is the source of truth for all things dealing with the schema, and that cannot be distributed. There's too much risk of corruption if that's distributed. The infrastructure master it basically keeps track of where things are. The domain naming master is in charge of all the different domain names, the forest, the trees, and so forth. You have these sort of master identifiers of all objects in a hierarchical database structure, and the RID masters was responsible for all of those unique identifiers. So that has to be there in order for to do certain things. And then the PDC emulator master, which is basically what the PDC emulator master does is it replicates the old functionality where you had a primary domain controller in Windows 2000, which again that's no longer the case in 2008 and 2012. But if you are if you need backwards compatibility to older versions of Active Directory, then you'll need the PDC emulator master role. But that one's not necessarily required. The other four, while they are required, if any one of those goes down, and that's what a lot of students in class will say to me, great, we have this awesome distributed database that's impervious to failure because it's distributed. There's no single head that's in charge, right? Think about going into battle. If you can take out the leader, then, that gives you a significant advantage, right? Because no one knows what to do. But the idea behind a distributed database is there is no leader. There's no single unit that you could take out, right? But now we have all that stuff again because now we have these single masters. But let's think about this. If the schema master were to go offline, what would happen? What would I not be able to do? Well, I wouldn't be able to make changes to my schema. But all of my existing schemas would still work. Everything would continue to run just like it normally would. It's just that if I try to make a change to the schema, I can't do it because the schema master is not online to process that change. Likewise, if I try to create a new domain, if my domain naming master is offline, I can't create a new forest or create a new domain or rename a domain or any of that stuff. That will be offline. But as long as I'm not trying to do any of that stuff, it's okay if that server's offline. As long as I'm not trying to do any of that. If you're trying to join a server to the domain, or you're trying to create objects, create user accounts, if the RID master is not online, then that stuff won't work. But as long as you're not trying to make those changes, everything will work fine. So it is important to understand a little bit about those FSMO roles, what they do, so you know what's not going to work if the server that's handling that role isn't working. You can remove this role. So if you have a server that's the schema master, you can remove that role from that server so it's no longer the schema master, but you have to be careful that if you remove it, that you have somebody else that's going to take over that functionality. Otherwise, you won't have a schema master. And if somebody tries to make a change to the schema, it won't work. So you have to be careful about that. Just like everything else, you can use the PowerShell to view the FSMO roles and see what FSMO roles are installed and so forth. There's this concept called trust relationships in Active Directory. So a trust relationship defines whether and how security principals from one domain can access network resources in another domain. In other words, if you're trying to log into domain 1 and you're a user in domain 2, how is it that domain 1 can trust what's in domain 2? And it's that trust relationship. There's this transitive trust relationship between these different domains and objects. Trust is not equal to permissions, though. In other words, just because a trust relationship exists between domain 1 and domain 2 doesn't necessarily mean that you're going to be able to log into domain 1. It just means that if you're allowed to, you can. Those permissions still have to be configured correctly in order for you to access that. All right, so a forest. All domains in a forest share some common characteristics. They have a single schema, right? So we have one schema master, which I talked about earlier with those FSMO roles. A forest-wide administrative account, so they all share that same forest-wide admin account for the domain. They have operations masters. They have a global catalog, which we're going to talk about here in just a minute. and trust between their domains and replication between those domains. So a global catalog, the first domain controller installed on a forest is automatically designated as a global catalog server, but you can have additional global catalogs. So what exactly is a global catalog? So think about a really big network with lots and lots of network objects, users, and so forth. Well, if this is a distributed database, that means that any change in any database in any domain would have to replicate across the entire forest. But in reality, that's not needed. What are the odds that a user from domain 1 is going to need to log into a computer on domain 15, in a completely different group or something like that? It's not common. So we don't have to replicate everything. And not everything is replicated. Only, and this is where the global catalog comes in. So a global catalog server has the full network, so it has everything on it, but it has information about every single user in the entire forest, and it has information about all of the different domains in the entire forest and other types of objects, but it doesn't store everything. It doesn't have the full schema. So it has enough information that if you wanted to log in from one domain and you're a member of a different domain, as long as you put your UPN, or the user or principal name, so basically a UPN is, rather than just putting in your username, you put your full username in. So for example, if the domain is thebank.com, but I'm in the St. Louis.thebank.com domain, when I go to log in, I have to, let's say I'm in Kansas City. In order to log in Kansas City to my St. Louis account, I have to put, Brian at Kansas City .thebank.com. And then the local domain there will know that I'm not trying to log in with an account on that domain. I'm trying to log in to a different domain within that forest. Now, of course, if that domain's not in the forest and no trust relationship exists, then it won't let me log in. But as long as there's a trust relationship there, excuse me, and it's within the same forest, it'll allow me to log in, and the global catalog will have that information cached about my user account. So that's what the global catalog is. So you usually want to have global catalogs in each domain. All right, so the forest root domain, the first domain is always the forest root domain. It's referred to as the forest root domain. It's imperative to the functionality of AD. If you don't have the forest root domain, the entire structure falls apart. So whatever was the root domain must be there, unless you make significant changes in the structure of your network. So the functions of the forest root domain, it usually handles it's usually the DNS server. It has the global catalog server. The forest-wide administrative accounts are there, and the operations masters will typically be there as well, though they don't have to be. So this is what a real structure will look like in a in Active Directory in a forest. If you recall, we saw an image similar to this earlier, but I told you that this is probably not what it would look like in reality, because you need that root domain. So in this case, the forest root is coolgadgets.com, and within coolgadgets.com you have the us.coolgadgets.com. You have, it says US there, but let's pretend it's uk.coolgadgets.com, right? Two different domains. And then on the right, you've got niftytools.com, which has a couple of subdomains under it, Americas and Asia, for example. So, but under all that, so even though niftytools.com is not coolgadgets.com, right? It's not coolgadgets.niftytools.com, it's just niftytools.com, but it's subordinate to coolgadgets.com. Coolgadgets.com is the root domain, and there is a domain called niftytools.com, which is in the forest, but it is not the root, although it is the root from the perspective of Americas and Asia. But the parent to all of this is coolgadgets.com. So if I were coolgadgets.com and I acquired niftytools.com, then niftytools.com would become another tree in my forest that is subordinate to that coolgadgets.com root. I hope that makes sense. That's kind of an important concept, but you can find this image in your textbook as well. All right, so domains and trees, organizations operating under a single name internally. Usually an AD forest with only one tree is best. So if you just have one name for the whole organization, usually just one domain in a forest, so one tree in that forest will work just fine. But when two companies merge or a larger company splits into separate business units, then you might have a multiple tree structure, which makes sense. But for most small and medium-sized businesses, choosing a single domain makes the most sense for simplicity. It's lower cost, it's easier to manage, and it's easier to access resources. So if you can, the moral of the story here is if you can, it's best to use a single domain if it's possible. But a single domain structure, while it's usually easier and less expensive than a multi-domain structure, is not always the best solution. So sometimes, and there's a reason that Microsoft gives us this option. Sometimes there's a better way to do this. So using more than one domain makes sense, or could be a necessity if you have different account policies across different areas of the organization. If you have a need for different naming entities, in other words, you've got two different companies that operate under, or two different flags under one company, for example, one company with multiple different names or doing business with different names. Replication control. You might have a need for internal versus external domains. The tight security, it gives you more granularity and security when you have this more intricate structure with domains. All right, so in the next slide deck, which is going to be the final one for this unit, I'm going to talk about group policy.